So for this video, I'm going to work on bulk modulus of elasticity and compressibility. So I have one question that I'm going to go through, and I've attempted this question. Okay, so I've written the question out here and just get started. So from the main color, I'll probably be using just be white, and then if I have anything which I've forgotten, I'll add it in red. I think that should be alright. So I'll read the first question. Okay, so I'll read it here. So an aluminium, so B, I don't remember what that means. I think it's bulk modulus. So aluminium bulk modulus of 70 times 10 to the 9 Newton meters squared, with a radius of 0.5 meters, falls to the bottom of the sea where the pressure is 150 atm, which is the atmospheric pressure. So part A is, what is the original volume of the ball? So original volume means that volume hasn't changed. So just draw a sphere here. So somehow that should look a bit 3D. So to know the volume of a ball or sphere, the equation is 4/3 pi r cubed. That's the equation that we'll be using here. So substituting that, knowing that the radius is 0.5, do it cubed, that should give the answer. So this gives 1/6 pi, which is basically 0.524. Sorry, why did I write 3? 24 when it's rounded, and that would be meters cubed. Do not ever forget units. So that was relatively easy because it was just using one straightforward equation. So that's for part A. And then for part B, so it asks, what is the change in volume? So we're looking for the change here. So we've been given the original volume, and what we do know, or what should be known, is change in volume should be, I believe it's the the change in volume will be final volume minus original volume, which we worked out in part A. But the thing about this particularly is that we don't have the final volume, and there should be also an equation linking the pressure to the volume and also the bulk modulus, which is given here. So if we wanted to look for the final volume, we probably want to see what is the radius at the end, because the radius would change, and we haven't been given any other radius other than the original radius, so this equation cannot be used. So the equation which links the change in volume to the pressure and bulk modulus is this one over here. So the change in volume is negative pressure multiplied by the original volume, so that is V0, over B, which is the bulk modulus. So this one would work for this question because we've been given these values, and that's what we're working with. So to find the change in volume, again, we will substitute these values in. So negative, so the pressure is 150 atm times the original volume, which would be 0.524 over the bulk modulus, would be 70 times 10 to the 9. Now, in concerning this one over here, we can't necessarily be using that unit, the atmospheric pressure unit, for using or for working at pressure. So to work out pressure, we need to work rather in pascals. So we'll need to convert that. It's a bit like saying if you have been given 1 millimeter, you won't use 1 millimeter if you're doing normal modulus, so we FL over AE, and if the extension is 1 millimeter, you need to convert the extension to 1 meter instead. Well, at least 2 meters. So therefore, it will be 1 times 10 to the 3, minus 3, meters. And that's what you use. So in the same way, we can't use ATM, rather we need to use pascals. Okay, so, I believe it's 1 is something pascals. 1 ATM is 101,325 pascals. So now we could use ratio here, and if we have been given 150 atmospheric pressure, you could just times that by 150 to get there. So we'll times this by 150 to get to this. And that would be so this very long number is what it gives. And that could be simplified to maybe 1, 2, 3, 4, 5, 6. Oh, it's supposed to be 7. 7. So rather it would be, oh yeah, rather it would not be 15, it would be 1.52. Sorry, so 5, 2 times 10 to the 7. I don't know why I did 15, that was really silly. There. So that will be simplified to that. So, could replace this with minus 1.52 times 10 to the 7. So since I already have the actual long value in my calculator, I won't be using this simplified version. I'll just use the value on my calculator. So I'll give more like an approximate answer for this. So the answer is minus 1.13 makes 1.14 rounded times 10 to the minus 4. And that's changing volume, so still meters cubed. That should be the answer for that one. For part B. Now for part C, what is the new volume of the ball? So this is now when we'll use this equation over here. So we've been given the final volume, which is minus 1.13 times 10, times 10 to the minus 4, I believe it is. Yeah. And the reason why it's negative is because if you are underwater, so I'll just get blue here. So if you're underwater, you're on the shallow end, there are less particles on top of you in the shallow end. So pressure is also concerning how many particles are on top of you. So you can just imagine like just small water particles. There are not that many particles on top of you if you are found in the shallow ends, like over here. It's not too bad. So the pressure is not, so you have low pressure. It's not a big pressure. But then when you get to maybe the deeper end, then you have more particles on top of you. Doesn't mean there's more water particles, it's just these, you have the shallow end plus the deep end of the deep. So you have all the particles on top of you, then if you're found at this X position, you have more pressure. You experience more pressure than the top because there's more particles on top here and they have more weight because the weight is just being added on. But on top of here, if you're near the shallow end, it won't be so bad. So the reason why the volume decreases is because when you get to the deeper end, the particles are compressing the sphere. So you can say the sphere is over here. So the sphere is being compressed. You have force acting on all sides of the sphere. So as the forces compress the sphere would obviously become smaller due to the force it is experiencing, or you could say the stress it is experiencing and it's being compressed. So therefore, that is why the volume is negative, because it is going down basically. Well, not going down, that's not good terminology. It is becoming smaller. And it's a bit like a number line. If something's becoming smaller, then it will go closer to 0 and then closer to the negative numbers of the number line. So that's just explaining why it is negative. Now, the original volume we also have, which was worked out in part A. So now we know that change in volume. Actually, sorry, we worked out the change in volume, so we need to find the final volume. That is my mistake. So we don't know that. Change in volume is the minus 1.14 times 10 to the minus 4. Therefore, if we know that change in volume is final minus original, therefore rearranging the equation, bringing this to that side, it will be plus, yeah, because it's basically negative original. So if you bring it to the other side, it'll become plus a positive. So bringing that on that side, it'll be the change in volume plus the original value. And that would give you 0.5238. And you would expect the volume to be smaller than the original because due to the pressure, it will become smaller. Seen as far as the change in volume is negative. So negative change in volume, same principles. It's a bit as if you're going closer to the number line and counting down. So you're going closer to the negative numbers, meaning that the size is becoming smaller. So positive change means that the volume will be getting bigger, and negative change means that the volume is getting smaller. So I'll continue with part D and E later because my volume, my battery is quite low and I don't think I'll be able to get through them at the time. But these are the questions currently right now.